Hi everyone, welcome for this refraction of light revision class. We are going to be doing some very important questions on refraction of light, and I'm going to make the concepts super easy for you. I'm going to show you the tips and tricks of how to solve these questions. So hopefully you'll find this refraction of light revision class very useful. So friends, are you ready and excited for this class? Let's begin. And before we start, I want to tell that we have this website manochaacademy.com. So guys, do check it out because we've got these awesome courses for you in physics, chemistry and maths for CBSE class 9 and 10 and for ICSE class 9. And we are adding more courses, guys. So thanks a lot for your love and support, and do share it out with your friends because in these courses, you're going to attend more live classes from me. We have interactive videos, quizzes and questions. So guys, do share it out, and they're on big discounts right now. Okay, so I want everyone to check the website and see if it's useful for you, and I can assure you that these courses will be very helpful in your preparation. All right guys, thanks a lot for your love and support, and yes, we are definitely going to be adding more courses to these website. All right guys, so are you ready and excited for this quiz? Good evening everyone, hope everyone's doing fine, and please guys, take care of your health in this difficult time, and let's go ahead and start with this quiz. Here's the first question. Which of the following can cause refraction of light? Is it rectangular glass block, a prism, is it a concave lens, or all of these? What do you guys think? Come on, I want all of you to try here. So which one will be the option here for this question? And awesome to see the participation, guys. And make sure you've hit the like button for this quiz. So in case you guys haven't hit the like button, please hit it right now. And also make sure you've subscribed to our YouTube channel, Manocha Academy. Right? We have this YouTube channel. Please do subscribe and click on the notification bell. And we also have a Hindi channel, Manocha Academy Hindi. So you guys can subscribe to that also. I keep taking live classes on this channel and the Hindi channel. All right. So what will be the answer? Which of the following can cause refraction of light? So guys, you know that refraction of light means bending of light. Okay. Bending of light. As you saw in the initial picture here, right? Can you see the pencil appears bent in this picture? Can you see that? Because there's water there, right? So refraction of light is bending of light. So which of these can cause it? So if you look at A, what is A? A is a rectangular glass block. And guys, you know that when light is incident on a glass block, it can definitely cause bending, refraction of light, right? The diagram is something like this. Okay. What about the next one? B. B is a prism, right? So prism, guys, you know, is this triangular shaped glass block, right? It looks something like this. And what is the rule of the prism? When a ray of light, right? I'm taking a monochromatic ray, which is made of a single color, let's say red color. When it is incident on a prism, you know, it bends towards the base of the prism. So something like this. Okay, this is just a rough diagram. All right. So prism can also cause refraction of light, guys. Right? What about a concave lens, guys? Concave lens, you know, it's thicker at the edges and thinner towards the base. So guys, you know that when you incident, you know, light on a concave lens, it will diverge the light. Okay. Concave lens is a diverging lens. Okay. So lens also causes refraction of light. So guys, very good. As you can see here, excellent. I see most of you have written the correct answer, D, because a rectangular glass block causes refraction, a prism causes refraction, bending of light, and you can see even a concave lens. So fantastic. I see Albert Einstein has also written all of them. Fantastic, guys. The answer is going to be all of these here. Awesome. Let's go to our second question. What is the nature of the image formed in a concave lens? So guys, you can see I've got this picture here of a concave lens. Is it always real? Is it always virtual? Real or virtual, or none of these? What do you guys think? So come on, I want all of you to participate here. So here you've got the picture of a concave lens, right? Guys, this is a concave lens. And what type of image can a concave lens form? Very important questions. You must understand this, right? So one trick is the concave lens the complicated one or the convex lens with respect to the types of images formed? What do you guys think? Okay. So, right, you guys know that a convex lens, right? A convex lens, okay, let me spell that correctly. A convex lens, which looks something like this. So convex lens is the opposite, right? It's thicker in the center and thinner at the edges. This guy can cause all types of images, right? It can produce a real image or a virtual image, right? So convex lens can produce real or virtual. Okay, but a concave lens, it always produces a virtual image, always forms a virtual image. And this virtual image, as you guys know, it is always upright. So it's always upright and it is always diminished, right? A concave lens always forms a diminished image. So these are the important properties. Please remember that for a concave lens, the image is always virtual, upright and diminished. Okay, let me write that a bit clearly for you here. So properties of the image formed, right? So let's write that down like this. So properties of the image formed, properties of image by a concave lens. It's going to be virtual, right? Upright and diminished. Diminished means smaller in size. Excellent, excellent. I see Aksh Gupta has also got the correct answer. Fantastic, guys. So in this option, it will be always virtual. Very good. I see Priyanshu has also got the right answer here, B. Right, Janvi also. Excellent. Next question, guys. When light is incident along the principal axis of a convex lens, where does this refracted ray go? So guys, please take a look at this diagram. What do you think will be the answer here? Will this ray of light, will it bend upward, bend downward, go along the principal axis, or does it get reflected back? What do you guys think? Okay. So I see Sumangal is saying C, right? What do you guys think? Okay, great to see the participation here. Awesome, guys. Awesome. Animesh is saying C. Thunderstorm Gaming also C. What do you guys think? So here, the interesting thing is when it's going along the principal axis, guys, you know that this is called the principal axis, right, of the lens. So this portion is this straight line going straight through is called the principal axis. And it passes through this optical center, right? Do you guys know? So this point here in the center of the lens is called the optical center, right? And it's usually written as O, okay? So when light is incident, right, on the principal axis, and it, you know, when it hits the optical center, you know what the, for the lenses, what is the rule? The ray will go undeviated, means there will be no bending. So it will just simply go straight through, right? Along the principal axis is the correct answer. Fantastic, guys, fantastic. So it will go undeviated along the principal axis because it is incident on the optical center of the lens. Okay, great, guys. Let's go to our next question. What is the correct formula for Snell's law? You know, there's important Snell's law of refraction. So which one is the correct formula? Sin I equal to sin R, sin I by sin R is constant, sin I greater than sin R, or I by R is a constant. What do you guys think here? So have you heard of the famous Snell's law? Come on, I want all of you to try. And think of, think of something called refractive index. It is related to Snell's law, right? So excellent, guys. Come on, please try here. So what does Snell's law, famous Snell's law say, right? He says that Snell's law says that the sine of I, what is I here? The angle of incidence divided by the sine. Sine means, you know, the trigonometrical ratios, right? You guys know sine theta, you've heard of this? It's basically if you have a right triangle, it's the perpendicular by hypotenuse, right? So you can watch my maths class on trigonometrical ratios. I have put quite a few videos on trigonometry. You can just search for Manocha Academy trigonometry if you want to know about sine theta, cos theta, tan theta. Okay, so it's this ratio, not simply I by R. It is sine of the angle of incidence divided by the sine of the angle of refraction, right? And Snell found that this ratio is always a constant, right? So when you take for a given pair of medium, right? It's not for everything, right? So for a given pair of medium, right? So when light is going from, let's say, medium 1 to medium 2. So if you have light, going like this from medium 1 and it bends at medium 2, the bending of light, refraction is caused by the change in medium, right? So when you have this, and this will be your angle of incidence here. So let me show you. This is the angle of incidence. This is the angle of refraction. So if you take a pair of media, let's say, air and water or water and glass, right? Then this ratio of sin I by sin R is going to be constant. Fantastic, guys. You guys rock. Awesome. Excellent answer. I see Sanjay Singh has also written that, right? Ayush Mondal, fantastic. So sin I by sin R, constant, please remember. And this ratio is also evaluated as the refractive index of the second medium with respect to the first one. Excellent, guys. Next question here for you. Which of the following can cause dry leaves to burn when sunlight falls on it for a long time? So if you have sunlight falling, let's say on a rectangular glass block or a prism or a convex lens or a concave lens, which of them can cause the dry leaves to burn? What do you guys think here? Come on, I want all of you to try. So let's say you have some dry leaves, okay? I'm not a great artist, but I'll just try to draw them for you here. So let's say you have some dry leaves, okay? So you have some leaves here, all right? So let's say you have some leaves lying around and you have sunlight, okay? So normally when sunlight falls on the leaves, right, they don't burn. But how can you burn them? Can you burn them with one of these things? Come on, guys, please think. And sorry if I'm not able to take everyone's name, but I'm constantly looking at your answers in the chat. So excellent, guys. What do you think? Okay. Some of you are saying concave, some of you are saying convex, some of you are saying prism. So guys, I want all of you to decide, and also please hit the like button right now and make sure you share our channel with your friends. All right, guys. So come on, I want everyone to try here. So awesome response from all of you here. Okay, so think about it. So a rectangular glass block, it can bend light, right? So if you want to burn the leaves, so think about this thing. If you want to burn the leaves, if you want to burn these guys, then you want to focus the sunlight on it, right? Think about it. So you want to focus the rays of the sun, right? So you want to focus the rays coming from the sun onto these leaves, right? You want to focus the rays of the sun on these leaves. So what are you going to put here so that the sunlight will get focused, right? The sunlight will get focused on these leaves and cause them to burn. So the temperature is going to increase and these leaves will start burning, dry leaves, okay? So which kind of thing, right? So something that will converge the light rays. So that's my hint to you. Excellent, excellent. Now I see a lot of you are getting the correct answer. The correct answer is a convex lens. Fantastic, guys, because a convex lens is a converging lens, right? It is a converging lens. And it converges the parallel beam to this point. This point is called the focus, right? It converges the parallel beam of light to the focus of the lens. Okay, excellent. So the correct answer here is going to be, you can use a convex lens to focus the sunlight onto the leaves, and then the temperature will increase, right? And this will cause the leaves to burn. Superb, guys. Let's go to our next question here. So this is an interesting question. A fish in a lake is looking at a tree on the edge of the lake. How does the tree appear to the fish? Does it appear shorter, the same size, taller, or none of these? What do you guys think? Come on, I want all of you to try. It doesn't matter if your answer is right or wrong. We are all learning here. Please participate. And guys, if you like our live classes, do check out our website, manochaacademy.com. I take more live classes there. We have these full courses for physics, chemistry, and maths. So you can check them out and do share it with your friends. The website is manochaacademy.com. And guys, if you haven't hit the subscribe for our YouTube channel, please hit it right now and click on the notification bell. Thanks a lot, guys. Thank you. Come on, try this question. So think about this scenario here, right? The fish is in water, okay? And the tree is outside in air, right? So the tree is in air, and as you can see, the fish is swimming nicely in water, right? Okay? And guys, you know that water is a denser medium compared to air, right? So air, we can say, is a rarer medium. So I'll write R over there. And water is a denser medium. So we'll write D. So definitely the light is going to bend, right? Okay. Now, one important thing, you know, a lot of times you make this mistake that you draw the light rays from the fish. So should I draw them from the fish or from the tree? What do you guys think? So who's our object here? Is it the tree or the fish? Come on, guys, tell me. What is the object here? Is it the tree or the fish? What do you guys think? The tree is the object. Absolutely right. Because the fish is the observer here. Fish is looking at the tree. Tree is our object here. So the light rays are going to start from the tree, right? So let's draw them. So let's say there's one light ray goes like this. Okay. And to form the image, you should draw two light rays. So we're going to go and draw that. And let's draw another one here. Okay. So we've drawn two light rays and we have taken them from the top of the tree. Let's say here. Okay. Now what's going to happen to these light rays? Basically these light rays, when they hit, when they hit the water, are they going to bend towards the normal or away from the normal? What do you guys think? Please think here. How will the light rays bend? Towards the normal or away from the normal? Because you know refraction is bending of light when it goes from one medium to another, when there is a change of medium. Refraction doesn't happen if it's traveling in the same medium, right? So excellent, guys, because it's going from a rarer, light is going from a rarer, from air to a denser medium, water, light is going to bend, absolutely correct, towards the normal. So let's draw that here. So I'm going to show some bending towards the normal here. Okay. Again, this is just a rough diagram here for you guys, right? So the light bends towards the normal. Now, what will be the image of the tree? You're going to trace back these rays, right? So let's trace back the rays here because they are divergent rays, right? So we're going to trace it back and let's see where they meet. Okay, wow, they're going into the question now, all right? So again, this is just a rough diagram here. So let me draw it, you know, a little more appropriately here. So these light rays are going to meet somewhere here, let's say, okay? And so what's going to happen is that is going to be the top of the tree where they're going to meet, right? So the tree is going to appear something like this. This will be our image of the tree, right? And those will be the leaves here. Can you see that? So what happens? The tree appears shorter or taller to the fish because the light has bent towards the normal. And when you extend it back, fantastic, guys. The correct answer is, right, the tree appears taller. So normally when we look at a swimming pool, you know, when you look at a lake or a swimming pool from outside the water, right? When you're looking at it from, you're standing in air and you're looking at water, then typically the pool appears shallower, right? But now, since the fish is looking at the tree, because the fish is in water, the tree actually appears taller. And you can see that by the diagram. Don't believe me, please draw this diagram, practice these ray diagrams. And the key thing to remember is light going from rarer to denser or denser to rarer, and then you draw it accordingly. Excellent, guys, excellent. The correct answer is going to be C. Let's go to our next question here. The refractive index of water, fused quartz, benzene, and ruby are given as shown here, right? 1.33, 1.46, 1.5, and 1.71 respectively. In which material does the light travel the slowest? So you have been given some refractive index values here for water, fused quartz, benzene, and ruby. And you can see, guys, the values are written 1.33, 1.46, 1.5, and 1.71 respectively. So come on, I want all of you to calculate in which material does light travel the slowest. Okay, what do you guys think? Come on. So what do you think is the answer going to be here? Right? So you know that what is refractive index? A refractive index of a material. What is the definition? Refractive index. I'm going to just write it as RI in short, right? So refractive index of a material, right? If you're talking, typically we take the light is coming from vacuum, right? Or air. So we can say, is the speed of light in vacuum or air? All right. So let's write that. We denote that by C divided by the speed of light in the medium. Okay. C by V, where what is speed of light? Speed of light, C is speed of light in vacuum, right? This is speed of light in vacuum, and V is the speed of light in the material. So speed of light in the material. So you can, you can change this formula and you can say the speed of light in the material, what is it going to be? Speed of light in the material is basically going to be C by V. C by Ri, right? The refractive index. And refractive index is also denoted by this, N kind of symbol, right? So we can write V is equal to C by N. So guys, now based on this, this formula, what do you guys think? If the refractive index value increases, will the velocity increase or decrease? V is the speed or velocity of light, right? What do you guys think? Okay, so clearly you can see that if the refractive index is higher, right, the speed will be slower because it's in the denominator. It's inversely proportional. So if the refractive index value is higher, the speed of light will be lower in the material. So we have to find the material in which speed of light is slowest. Okay, and this formula I've written, guys, it's called absolute refractive index when you're comparing it to vacuum, right? So what is the answer going to be? It's basically going to be Ruby. Fantastic. I see a lot of you have got the right answer because Ruby has the highest refractive index here. So light will travel the slowest in Ruby. Can you see? 1.71 is the highest value. So the speed of light, so higher the refractive index means the speed of light in the material will be slower. All right. Excellent. Excellent, guys. Fantastic. Let's go to our next question. If the focal length of a concave lens, so you can see there's a concave lens here, is given as 2.5 meters, what will be the power of the lens? Guys, you need to find the power. And I'm sure you must have heard this term, right? A lot of people say, you're wearing eyeglasses, like I'm wearing spectacles or eyeglasses. A lot of people ask, what is your power, right? You've heard of this term, power of the lens, which tells you the degree of convergence or divergence of the lens. So how do you calculate this power? Or when you go to a, optician or ophthalmologist, they give you the power of the lens. And you check the prescription, it's written in D, capital D stands for diopter. So come on guys, awesome, please try. So what is the key concept here? What is the power formula? Power basically has two important formulas. You can write it as, the basic formula is power equals 1 by the focal length when it is in meters. So you can say 1 by F in meters, or there's another formula which is convenient one, which is 100 by F in centimeters. So if you're using the focal length in centimeters, then you use 100 by F, and meters is going to be simply 1 by F. Okay, please remember these two important formulas. All right, guys. So now come on, use this formula and easily find, I'm sure you can find the power. So what is the focal length given to us in this question? So focal length is written as 2.5 meters. That's been given, right? So let's substitute this value in this formula. So we're going to use this formula because we have been given in meters. So what is P going to be? P is going to be 1 by F in meters, which is basically 1 by 2.5 meters, right? And what is that going to work out to be? 1 by 2.5, it's 0.4 diopter. Okay. So now one question is, there are two options here, right? There's a minus 0.4 and a plus 0.4. So what do you guys think? Which one will be the answer here? Will it be plus 0.4 or minus 0.4? Come on. And for the people who wear eyeglasses, spectacles, there's a positive power, there's a negative power. So what do you guys think? So some of you are saying C, some of you are saying D. So definitely A and B is not the answer, right? It's going to be 0.4. So which one? So guys, remember this very important rule, okay? So I would say that you can remember it this way. Most of, the people, the students, most of the people in your class, since you guys are young, right? So most of the young people, they have myopia. Those people who have, who wear eyeglasses. Of course, if you have normal vision, then you don't need to wear spectacles. But most of the people like you and me, we have myopia, which is short-sightedness, and we wear concave lens. And concave lenses, guys, have negative power. Please remember that. A concave lens has negative power. You might have heard this. What is your power? -2, -3, -0.5. Okay. So will you remember this for me? That a concave lens, guys, has negative power. Why? Because it has a negative focal length. There's a reason for that. Because the focus lies on the negative x-axis. Okay. You can research that. It's based on the focal length. So actually what we wrote here, it's not 2.5 meters, it's actually -2.5 meters because the focal length of a concave lens is negative. And that is why, it becomes minus here. And so this answer will be -0.4 diopter. A convex lens is opposite. It has positive power, positive focal length. All right. Excellent. So the correct answer is going to be -0.4 diopter. Very, very important. And I want you guys to remember this in the simple way. So just remember this thing that a concave lens has negative focal length and negative power. And you can remember that with the example, most of your friends or, or maybe you, right? You guys are having myopia. You guys have negative power. You're wearing a concave lens. Please remember that in your eyeglasses. Okay. In your spectacles, you're wearing a concave lens. And so you have negative power. Clear? Awesome, because you are having myopia, short-sightedness. So the correct answer is going to be -0.4, and this D stands for diopter, right? This unit is called diopter, and it's usually spelled like this. Okay, excellent. Next question, guys. If the object distance is 20 centimeters and the image distance is 50 centimeters for a spherical lens, what is the magnification? Come on, I want all of you to try. And guys, if you haven't hit the like button, please hit it right now. Great to see more than 300 likes. Thank you, guys. Thanks a lot for your encouragement. So I want all of you to hit the like button right now and do share our channel with your friends. Okay? And everybody, please participate. Thanks a lot. Thank you guys for all the likes. So let's go ahead and try this question. Awesome. So what will be the magnification here? So magnification, what is the formula, guys, for, so again, we are doing the topic of refraction. So we are doing lens, we are not doing mirror. Okay. Wow. Great to see 347 likes. Great. Awesome, guys. So we are talking about lens. So what is the formula for magnification of a lens? Right. So, magnification, one simple formula is image height by object height, right? H dash by H. But for a lens, right, that works out to be image distance, right, divided by object distance. Here V and U is not velocity. Okay. What is the meaning of V? V is basically the image distance divided by the object distance. And again, we have to consider, that whole sign convention, positive, negative. Okay. But nothing is given here. We just given, there's a spherical lens. So we have to assume these to be given as positive. Okay. Otherwise they should have been given with the sign. So it's a little tricky question if you look at it that way. So basically the object distance given to you is 20 centimeters, right? The image distance V is 50 centimeters, and we will have to assume these to be positive because no sign has been given, right? So it's basically plus 20 plus 50, and we are going to find the magnification using this formula. M is V by U. Okay. For a mirror, it's minus V by U. For a lens, please remember it's V by U. Very important, the signs. Okay. So let's go ahead and substitute the values here. So M would be V by U, which is basically 50 by 20, right? And centimeters. But it's a ratio, so the centimeter is going to get cancelled. And what are we finally getting? Excellent. Awesome, guys. I see a lot of you are writing the answer C. That's absolutely correct. 2.5 is the right answer here. So this is how you find the magnification. All right. Excellent. Let's go to our next question, guys. if the value of magnification is -2, so this is the opposite question. They have given you the magnification value, then what can you say about the image? Is it a diminished image, an upright image, an inverted image, or you can't say, you can't comment? What do you guys think? Come on, be science detectives here and find the answer for me. So I want all of you to try here. Come on, guys. So Ayush is saying D, right? Shari is saying C here. Venkat is saying A. What do you guys think? Come on, I want all of you to try. Vidyasagar Reddy saying A. So magnification value has been given. So M is given to you as -2. Okay. And remember, magnification M basically means M is image height by object height, which you can write as H dash by H or HI by HO, right? Image height by object height, it's a ratio. Okay. So what do we know here? That HI by HO, the image height by object height, is -2. That's what's given to us, right? So therefore we can say, or image height HI is -2 times the object height. Do you guys agree? So I'm showing you a very simple way of how to look at this question. Please try, guys. So just work it out mathematically here. And let's say you take the object height to be 1 centimeter. So let's take the object height here as 1 centimeter here. Okay. So we'll just assume something just to make it easy. So we can say, let this object height be 1 centimeter. So what will our image height be? So if object height is 1 centimeter, image height works out to be -2 centimeter, right? Right? If we assume the object height as 1 centimeter, assuming, just to make the numbers simple. So now guys, what do you guys think? So clearly the image is not diminished because it is 2 times, it is 2 centimeters, twice as the object. So the first option is out. Okay. The image height we have got here, right? Image height we have found is -2 centimeters. That means it lies on the negative x-axis, negative y-axis, sorry. Remember the sign convention, right? So whenever you consider a lens, whether it's a concave or convex lens, you need to place the sign convention, the x and y axis, on the optical center, right? And since you've got a negative, right, the image height is negative, so it is on the negative y-axis. It's below the principal axis. So upright is wrong. So what we can say, the image is inverted. Fantastic. I see, right, Jintu Datta has the right answer here. Fantastic, right? And I see some of you have written, very good. So Meher Khan has the correct answer, inverted. Fantastic, guys. So can you see, because the if the object height, and usually the object is taken as upright. If the object height is 1 centimeter plus 1, so it's upright, the image will be inverted, right? -2. And clearly -2 means it is inverted and it is 2 times magnified, right? Twice the object height. So excellent. So that's the answer here. Next, let's try another question, guys. Right? Light enters from air into a material having refractive index of 2.5. What is the speed of light in the material? So come on, I want all of you guys to calculate. So you guys are doing great. Please try the next question here. Light enters from air into a material having refractive index of 2.5. What is the speed of light in the material? Okay, so guys, here we have to use again our refractive index, right? We have been given refractive index is 2.5. So you can write N is 2.5. Some of the books, you know, they use this symbol mu. So they write it as mu is 2.5. So whichever one your book is using, either that N or, you know, eta looking symbol, the N letter, or mu, okay, is 2.5. And you need to find the speed of the light in the material. So we need to find the velocity of light in the material. So what is the refractive index formula? What's the connection here? So guys, you know, the refractive index is the ratio of speed of light in vacuum, right, divided by the speed of light in the material. Do you guys know this famous formula? Refractive index is C by V. Okay, so come on, use this formula. And what is the, you know, speed of light in vacuum? You have heard of this famous Einstein's formula, E equals mc square. So it is that same c, guys, where c is the speed of light in vacuum. So what is the speed of light in vacuum? You guys know it is 3 into 10 to the power 8 meters per second. And that's not been given in this question. So you're expected to know that. Okay, guys? You need to remember 3 into 10 to the power 8 meter per second. All right? So please, yeah, very good. I can see a lot of you are writing the correct formula. So come on, substitute it and solve this. It should be easy. So you know all the values and we need to find V. So we can rearrange this formula and say V equals C by the refractive index, right? Simple. C divided by the refractive index. So let's go ahead and substitute the values. Come on, guys, very simple. So C is 3 into 10 to the power 8 meter per second. Okay. And divided by 2.5. So all of you, please calculate that and find that for me. What do you think the answer is going to be? Okay. Come on, guys, please try. So you need to find the speed of light in the material, it's saying, which has a refractive index of 2.5. Okay. So, you know, it's always good to separate that 10 to the power thing away. So what does this work out to be? We can write this as, this is basically 3 divided by 2.5, right? So we have a 3 by 2.5 and a multiplied by 10 to the power 8. Okay. Multiplied by 10 to the power 8 meter per second. Okay. That will be the velocity in meter per second. Do you guys agree? Okay. And let's quickly solve that 3 by 2.5. Let me show you a neat trick to do that. So if you have 3 by 2.5, one interesting thing you can do here is, let's say you multiply by 4. Okay. So when you multiply the numerator and denominator by 4, what do you guys get? Come on, do that for me. So if you do 3 into 4, you're basically going to get 12 in the numerator, right? 12 divided by 2.5 into 4 is 10. So if you just multiply by 10, you're going to get 12 by 10, which is nothing but 1.2. So you can really calculate this part really fast. 3 by 2.5 you can calculate by multiplying the numerator and denominator by 4. Okay. So what are we going to get here finally, guys? We are going to get 1.2. So the final answer is going to turn out to be the velocity in the medium V is 1.2 multiplied by 10 to the power 8 meter per second. Don't forget the 10 to the power 8. Very important. It's not just 1.2. So some of you guys are writing 1.2. That's absolutely right. Multiplied by 10 to the power 8 meter per second. This is scientific notation. You can also write 12 into 10 to the power 7. But you know, scientific notation, there's one digit, one non-zero digit before the decimal. So this is our final answer. And clearly you can see it is slower than vacuum because it's fastest in vacuum, right? Because the 2.5, the refractive index is 2.5. So the material slows down the speed of light from 3 into 10 to the power 8 to 1.2 into 10 to the power 8 meter per second. Awesome. Is that clear, this answer? So this is how you get this. This is your final answer. 1.2 into 10 to the power 8 meter per second. And this is the important formula we used, right? The speed of light, the refractive index of a material is speed of light in vacuum divided by the speed of light in the medium. Awesome, guys. Another question for you. If the focal length of a convex lens is 15 centimeter and the object is placed 20 centimeters in front of the lens, at what distance will the image be formed? So come on, I want all of you to participate, and thanks a lot, guys. We've got 400 likes here. So it's all due to your love and support. Thanks a lot for the encouragement, and I want everybody to try this question. Come on, guys. Awesome. And if you haven't hit the like button, please hit it right now and do share out our channel with your friends. So we've got this English channel, Manocha Academy, and I've also started live classes in Hindi in our channel called Manocha Academy Hindi. Okay. So, and we keep taking these live classes on YouTube at 8 p.m. right? So you guys can, check out, click the notification bell and you'll get the notification for the English live classes on this channel. And we also have a Manocha Academy Hindi channel. And recently I've started Hindi live classes because, there were a lot of requests for Hindi also. So, I've started those classes as well. All right. So you can watch whichever one you like and do share it out with your friends. Come on. Guys, try this important question. Here, basically, we are not drawing ray diagrams. We are going to predict it using the lens formula. So what have we been given? Always draw a rough diagram though. You don't have to draw a perfect ray diagram. So we have been given a convex lens, right? That means it is thinner at the edges. Okay, all right, let me draw a better lens. That's not looking so nice. Again, I'm not a great artist, and it's a little difficult to draw on the tablet. All right, so here, that's our concave lens, convex lens, right? And that's the principal axis here, right? Let's see if we can draw a straighter one. So yeah, that's better. Principal axis, and what does it say? The convex lens of focal length given to us is 15 centimeter. The object, okay, the object is placed 20 centimeters in front of the lens. So this part is 20 centimeters. At what distance will the image be formed? So we have to find the image distance here. Okay, and guys, the important thing is sign convention. So make sure you draw those x and y axis. So I'm just drawing it in dotted line here, right? So this is the x axis, the x dash, the negative x axis, y and y dash. All right, so make sure you draw them, and they are to be centered at the optical center of the lens, O. Okay, so please draw these axes because sign is very important here. And let's write down the data. So we have been given focal length, right? Focal length is 15 centimeters. So always ask yourself, is it plus 15 or minus 15? What do you guys think? So come on, all of you try. Is the focal length plus 15 or minus 15? In a convex lens, guys, you know that when a parallel beam is incident on the lens, the rays get converged on this right side. So you guys know the focus is to the right side of the lens, right? It's on the right. So it's definitely, because we discussed a convex lens has positive power, positive focal length. So very good. It's plus 15. Please remember that. It's a convex lens, right? Plus 15. So we must write with the sign. Always think positive or negative. Okay. And we have been given the object distance, which is denoted by U, is 20 centimeters. So guys, should I put plus 20 or minus 20 here for object distance? Very, very important. Sign is very important, guys, for the questions. So object, you can see it's on the left side of the lens, right? It's placed on the left side. It's on the negative x-axis, right? It's on the x dash, negative x-axis. Can you guys see here? The object is on the left side. So it will be very good. Minus 20 centimeters, negative. All right. What about the image distance? V. We need to find the image distance. So guys, will the image distance be positive or negative? What should I write? Which sign here? So what do you guys think? Will the image distance be positive or negative? Some of you are saying positive, some of you are saying negative. What about the image distance? Okay. So Mohammed Arif is saying positive, Sanjeev is saying positive. Okay. What should I take for the image distance? Positive or negative? But guys, we don't know. The answer is image distance is not known to us. So it's like algebra. You don't say plus x or minus x. It is simply unknown. Don't take the sign for what is not given. Okay. We will calculate it using our formula. And what is the famous lens formula? You guys know the lens formula is 1 by V minus 1 by U equals 1 by F, right? Where everything is substituted with the correct sign according to sign convention. Okay. So if it is unknown, please leave it as is. V should be a question mark. So come on, let's go ahead and substitute the values. So here we basically have 1 by V minus, and this is 1 by U. So we are going to substitute minus 20 here, right? And that's equal to 1 by F. And 1 by F is given to us as plus 15, right? So this is plus 15 here. Okay. So come on, simple, calculate this. So what are we finally going to get here? 1 by V, and this minus minus becomes plus. So we basically have plus 1 by 20 here is equal to 1 by 15. Are all of you getting that? Please check my calculations. I'm doing it live here, in case I make some mistake here, please check. So therefore, what are we getting? 1 by V. So from here, what do you get? 1 by V equals 1 by 15 minus 1 by 20, right? So guys, if you take the LCM, what are you going to get? The LCM is going to be 20 and 15 here. So the LCM is 60. And what is this going to work out to be? 4 minus 3 is what I'm getting. Are you guys getting that? 4 minus 3. So 1 by V is 1 by 60. Okay. So 1 by V equals 1 by 60. Therefore, V is 60 centimeters is the answer. Plus 60, right? Awesome. Very good. I see Sachin as the right answer here. Jay Reddy, excellent. Chandan, plus 60 centimeters. Superb. Gaming Gyan, very good. Oh, some of you got minus 60. Please check, guys. Is my answer correct? It should be plus 60, right? Please check. It's turning out to be a positive answer here. Please see the calculations. Because u is negative. Because u is to the left of the lens on the negative x-axis, right? So we substituted minus 20 here. And the minus minus becomes plus. And focal length of a convex lens is positive. Okay. So 1 by 15 minus 1 by 20. Definitely you're going to get a positive answer here because 1 by 15 is bigger than 1 by 20, right? So excellent. So we are getting the V is 60 centimeters. So how do you end this answer? You should write this and then you can write in words that the image is formed on the right side or, behind the lens or on the opposite side of the object. So whichever way you want to express it. So we can say the image is formed 60 centimeters behind the lens. 60 centimeters behind the lens, right? And the answer turned out to be positive. It was plus 60. So we didn't have to assume any sign. Whatever we get from this famous lens formula, please learn it, right? 1 by V minus 1 by U is 1 by F. Very important lens formula. Mirror only formula is same, only you have a plus sign here, right? It's 1 by V plus 1 by U equals 1 by F for spherical mirrors, and this is for lens. So awesome. The answer is 60 centimeters. Excellent, guys. And here's the final question for you, which is going to be a homework question. For absolute refractive index. So guys, research. What is this term? Absolute refractive index. So you guys might know speed of light of a medium is compared with air, vacuum, water, or diamond. What do you guys think? Okay, so when you talk about absolute refractive index, and this is absolutely a very important term, right? Absolute refractive index, the speed of light of the medium, is it compared with air, vacuum, water, or diamond? Okay, so guys, and a lot of you make mistake in the spelling of vacuum, right? So even, sometimes when I was writing down that option, I write VACC, it's W. Right? So which will be the answer? Air, vacuum, water, or diamond? I want you to write the answers in the comments below. And guys, if you haven't hit the like button, please hit the like button right now. Hope you enjoyed this class and found the refraction of light revision very useful. And guys, do share out our YouTube channel with your friends. Our channel name is Manocha Academy. We also have the Hindi channel, Manocha Academy Hindi. So guys, do hit the like button, do hit the subscribe button and the notification bell so that you don't miss a single live class. Great to see a lot of you are giving the answers here, but I won't tell you which one is the correct answer. Please research it and write your answer in the comments below and I'll reply to it as soon as possible. Okay, excellent, guys. And as I said, we have this website with these courses, and these courses are on big discounts, full courses for physics, chemistry, and maths, for CBSE and ICSE for class 9 and 10. So guys, do check it out. They're very useful because you get to watch interactive videos, which will help you revise your concepts. And I take more live classes there. So if you enjoy our live classes, I'm taking live classes for physics, chemistry, and maths also on our website where we complete the full course. There are quizzes and questions for you to practice and you get direct replies from me. So awesome, guys. Do check out our website and do share it with your friends. And also make sure you've subscribed to our YouTube channel so that you don't miss any of our videos or the live classes that we take here. All right. So yes, you can definitely check these courses out. As I said, they're on very big discounts because we want all of you guys to use it and benefit it. And what is my name? My name is Sandeep Manocha. And with this, I'll be signing off and have a great day. And awesome, guys. Awesome. You guys were very interactive, and thanks for all the likes and all the great comments that we keep reading, and all your answers here. I really enjoyed this class. I hope you guys enjoyed it too, and all the best with your studies. Keep the momentum going, take care of your health and keep studying, and I'm sure you guys will do well. All right, take care. And if you guys have any question, you can always find our email or phone number given towards the at the end of our website. It's contact@manochaacademy.com. So you can send us an email if you have any questions about these courses. So do check them out. And if you find them useful, you can take them and do share it with your friends. Awesome, guys. Awesome. And I will be taking more live classes also on our website and on the YouTube channel. And live classes on the YouTube channel are at 8 p.m. All right. Where do I live? Gaming Gyan is asking. I stay in Kolkata in India. So I'm from Kolkata in India. We're a Kolkata-based company. And hope you guys enjoy our classes and material. So thanks a lot and great to have everybody's support. All right, guys, I'll sign off. Take care, everyone. See you in the next class. And if you haven't hit that like button or the subscribe and notification bell, do that right now. And do check out both our channels. Manocha Academy is the YouTube channel for English. And we also have a Hindi channel where I've started taking some Hindi live classes. Thanks a lot. Thank you, guys. Take care. And I will end the class here. Bye-bye. Bye, everyone.